Right. So last time that we were looking at things, we were looking at free body diagrams. Now, we've looked at free body diagrams on a flat plane where an object would be staying still, which would allow for a force of gravity and a normal force. Well, if we have it on a slope, remember, even though we got theta, our force of gravity acts down. Normal force still acts up, and friction will act along the plane. If we break that down into a free body diagram, we could break it into the components of a force of gravity perpendicular, force of gravity parallel, and friction and the normal force. Those are what will be present on an object that is at rest, or essentially at equilibrium. Alright, okay. Now, that's fairly easy to remember. Remember, force of gravity is always acting down, and otherwise we can make them act and break it into its components. What is important to remember is if we break it into the components, the actual force must be drawn in dotted lines, so that it is not for marks. Okie dokes. Now, let's complicate things a little bit more by looking at objects where our force is being pulled up at a degrees theta. Alright, now the thing is, when we break it into this free body diagram components, we have an FA, but if we break it down into components, there is an FAX. Then this would be Fn, this would be Fg, and if friction is present, friction there. But because it's at rest, it's probably at rest. That because we've got an FAX on the right hand side, FAY will be at the top. Now, why is it that way? Because the resultant force, what we can say is that with the resultant force, it is based on multiple forces acting on an object, which will have the effect of one force. Now, we could also say the same thing backwards, saying that one force also has the effect of two different forces. So therefore we can break them up. So in this case, Fn plus Fay will equal our Fg. Whereas if we take an object where we are pushing down on the object with an applied force and theta, then our applied force acts in a different way. We still have that FAX, we still have Fg, we still have Fn, and we still have force of friction. So this is a static friction, by the way. Now, instead of our force of AY going to the top, it goes to the bottom, due to the fact that, again, we can break this component force, that main force, into its two components. These are the effects. Alright, so we'll have a look at those again. Maybe do an example. And yeah.